We'll be looking at the June 2022 paper. Sorry, not June 22, June 2024 paper, question 22. In this question, it's asking you about transition elements. And in particular, it's talking about iron. Iron is in the D block of the periodic table and contains S, P, and D orbitals. Draw diagrams to show the shapes of an S orbital and a P orbital. So single S and a single P orbital. Complete the electron configuration of iron atom and an iron 2+ ion. This is question 22A. First of all, if you have a look at the shapes of the orbitals, they've only asked you to draw the shapes. An S orbital is actually, you just draw like a big circle. And you want to think about this three-dimensionally. They've not asked for the name, but it's good to be, they can in your paper. The name of the shape is actually like a sphere, a round sphere. For a P orbital, remember a P orbital example, let's look at a 2P orbital. You've got 3 P orbitals at the same energy level. That's why it can hold up to 6 electrons. And if you want to draw just one of them, it's like a stretched out 8. And the name of the shape, you can call it like a lobe, like an ear lobe. Now, as for the electron configurations, the iron atom, if you look at the periodic table, in the periodic table, the atomic number for iron is 26. So an atom will have 26 electrons. Now on the right-hand side, just a reminder of how the subshells are filled. Now, in the syllabus, you're required to know up to 4P, which is the element up to and including krypton. Now, you see, if you write down the subshells like I've written down here in a numerical order, and each time we go up one level, an extra subshell is added. So what we're going to do, you need to follow the direction of this direction arrow. So you can have 1s, 2s, 2p, 3s. After 3p, it'll be, after 3s, it'll be 3p. This is where it gets very interesting. Students make the mistake that they think it's 3D filling after. No, it's not. It's going to be the 4s fills before the 3D. And the reason for that is because the 4s is at a lower energy level. That's why the 4s fills before. We can write that down. Oops. 4s at a lower energy level than 3D. So the electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p6. We've got up to 18 electrons, and we want to get up to 26. What happens next? We fill the 4s2 electrons, and that takes us up to 20. And then in the 3D subshell, you've got your 6 electrons. For the iron 2+ ion, it's going to be 1s2, 2s2. I'm going to write down the same thing again, but let's have a little look at, closer look at which electrons are going to be lost. You see, even the 4s2 electrons are filled before. We write the electron configuration in a numerical order. Now, as for the ion, even though the 4s2 electrons are filled first, they are also removed first when an ion forms. So you get rid of these outer electrons. And so the electron configuration will be up to 3d6. Next question. Now, I'll show you the color chart. You see, this is a flow chart, shows some reactions of cobalt to chloride. Now, in your syllabus, cobalt reactions are not shown in that much detail. You don't need to know that much about it, but you do need to know your understanding of other complexes that you've learnt and apply them to this question. So you've got cobalt chloride. When it dissolves in water, you're going to have excess water molecules surrounding the cobalt CO2 plus ion. And it's asking, identify A, B, and C. You see, the complex ion A is going to have, as we said, cobalt. It's going to be surrounded by 6 water molecules that all act as ligands. What is a ligand? A ligand is a molecule or an ion that donates a pair of electrons, forming a dative or a covalent bond. So you got your 6 water molecules, and the thing is, water has a 0 overall charge. That means the overall charge of the complex ion will be what the original charge of the cobalt ion is. Now, as for solid B, you see, they've given you these colors: pale pink, blue-green solution, blue-green solid, and blue solution. I believe this is the only color that you need to learn, as I'll show you in the chart shortly. But if you look over here, solid B, it's asking for the identity of what that solid B is. You know, they could ask you, you know, what is the, show the ionic equation for the precipitation forming solid B. You see, cobalt 2 plus ions, which are aqueous, they react with sodium hydroxide, as you can see here, and it reacts with the hydroxide ions, which is also aqueous, and it gives you cobalt 2 hydroxide, and the state symbol will be a solid. So the identity will be cobalt 2 hydroxide. Cobalt 2 hydroxide. Then it's asking you, what would the complex ion C be? You see, in this question, one thing to bear in mind is that to this original complex, you are adding concentrated hydrochloric acid. Now, the concentrated hydrochloric acid, I mean, you ask yourself, to a cobalt 2 plus ion, what's going to be attracted to it? What's going to act as a ligand? Will it be the H plus ions or the chloride negatively charged ions? It will actually be the chloride negatively charged ions, for obvious reasons. Opposite charges, they're going to attract. Now, the complex ion it forms, we've learned this with copper. When you add concentrated HCl to a copper solution, copper 2 plus solution, what you get, those 6 water ligands, get replaced or substituted with 4 chloride ion ligands. And the reason for that, the chloride ion is significantly bigger than the water molecules. It's actually 1 shell bigger. And also you've got 4 chloride ions that all have a negative charge each. So there's going to be a greater repulsion to them. That's why the coordination number is 4. Whereas with water, the coordination number is 6. They've used these words here as well: 6 coordinate, 4 coordinate. And so you got cobalt, which has a 2 plus charge ion, and each chloride ion is -1. So overall, the charge will be 2 minus. Next question is asking you, cobalt-3 forms an octahedral complex ion D. By the way, octahedral, what does it mean by octahedral? It's an 8-sided shape. That means your middle transition element is going to have 6 coordinate bonds, giving rise to an octahedral shape. You need to learn to draw these shapes. In this particular paper, they didn't ask for shapes, but in your paper, there's a high chance it could come. Learn your octahedral and tetrahedral and square planar shapes. The shape looks something like this. Something like that. 8-sided shape. So, which contains both ammonia. Ammonia is NH3 and chloride ions. Complex ion D has a molar mass of 197.9. Determine the formula and charge of the complex ion D. You see, looking at the numbers, the fact that we see 9 means that the number of chloride ions is going to be even number, because otherwise we would have got a 4 as the first decimal place. So we can assume, it's a game of trial and error. Let's assume that we're going to have 2 of these, and we know that there has to be 6 ligands in total. 1, 2, 3, 4, 5, 6. So let's try this out. Two chloride ions. Let's try 4 ammonias, and you've got 1 cobalt, 58.9. And if we add these up, and that happens to work out to 197.7.9. So it's asked you to determine the formula. The formula is going to be CO. You're going to have 4 NH3s. You've got 2 chloride ions, and cobalt has a 3+ charge. So +3 -2 overall gives you a minus charge. Sorry, +3 -2 gives you an overall +1 charge. Okay, this is the last question. It's about red blood cells. Now, red blood cells contain hemoglobin, which transport oxygen around the body. For efficient transportation of oxygen, healthy human blood must be maintained at a pH value, and they've given you this pH range. Human blood acts as a buffer. Now, buffer is a buzzword here. That's the key word that this question is based on. So we're looking at buffer solutions. Due to the presence of carbonic acid, H2CO3, and hydrogen carbonate, which is like its salt, its conjugate base ion. As shown below, you've got the expression over here. You've been given the Ka value. And so the Ka expression here is given below. The first point is asking you, explain using ligand substitution, how hemoglobin transports oxygen around the body. Now, what it does, oxygen, so this is the first point, oxygen, it forms, like we discussed with complex ions before, forms a coordinate or a dative bond with the iron in the complex. And when it goes around the body, where it delivers the oxygen, and in return, it gets replaced by carbon dioxide. And these are the 2 points that covers the first part of the question. Is then asking you determine whether a sample of blood with HCO3 minus concentration and H2CO3 concentration, just highlight this, ratio of 8.5 to 1 is healthy or not. Now, what they've done in this question, they have, let's see, they've given you this part of the equation. They've given you a value of 8.5 divided by 1, which is still 8.5. Let's make this 8.5. You've been given the Ka value, which is 4.27 times 10 to the minus 7. And what we want to do is work out the H plus concentration. So what we do minus log to the base 10 of H plus concentration. How do we work out H plus concentration? It's 4.27 times 10 to the minus 7. And let's divide that by 8.5. Let's see what that gives us. Minus log to the base 10, 4.27 to the power of minus 7. And then we're going to divide that by 8.5. That gives us a pH of 7.30. Is that healthy blood? The range is supposed to be 7.35 to 4.5, 7.45. So it is not healthy, as below pH 7.35. And ladies and gentlemen, that is the end of this question, and that is the end of this paper, end of question paper, and this is the end of this academic year, 2025, June, for chemistry and for the series of videos. I hope you've liked them. Any feedback will be most appreciated for future years. Yeah, any feedback, good or bad, will be appreciated, how we can maybe improve them. But, wish you the very best of luck. Oh, go back. Wish you all the very best. And I was just going to say, there's lots of things online to help you prepare for the exam on the day. Exam hacks and techniques. What can you be doing? I was just wanted to, just a couple of points there. One thing was that every mark is equal. Every mark is equal. Now, whether you do a really difficult question or you do sorry about that. Every mark is equal, whether it's from a difficult question or an easy question. So what you should really be doing, skim through the whole paper and do the easy questions first. Do the easy questions first, and while you're doing them, your supercomputer brain is already processing the difficult ones. And any hesitation, skip the question and come back to after. Skip difficult questions or time-consuming questions and come back to them after. And you'll find you'll make best use of time. Don't want to spend too long on this, but I'm sure you know what you need to do. There's lots of information out there on exam technique. I hope you have used these videos well, and I'll see you on the day of the exam. With that, ladies and gentlemen, thank you very much. It's been a pleasure doing these.